We're going to take a look at rational versus irrational numbers. So let's start with rational. What does that mean? Three things in order for it to be rational. It can be written as a fraction of integers. That means also whole numbers. What I mean by that is this. If I had 25 divided by 1, for example, that's a fraction of integers, right? Which gives me a whole number. All right, it can be a repeating decimal. What I mean by that is if I had this repeating decimal, it is repeating 0.3. Why is this an answer? Because I can go ahead and do that. And again, that's a fraction of integers. So it's just a different way of recognizing. Let's go ahead and write this example. So this means 25 over 1, which is equal to 25. A repeating decimal such as 2.33333, which is going to again be a fraction of integers, 7 over 3. It doesn't have to be repeating like that. It could be repeating like this, 356, 356, 356. That's still a repeating decimal. So even if you don't see this fraction, this is still repeating 356, 356, 356. That's the repeating part. And then a terminating decimal. What that means is something like 0.25 or 0.5. All right, it ends. A terminating decimal ends. So why is this a rational number? Because again, I can write it as a fraction of integers. Or if I had a terminating decimal, let's just randomly do that. It ends. In other words, it ends right here. So this keeps going, but that ends right there. Sometimes a fraction isn't there. For it to be rational, three things can be written as a fraction of integers or whole number. It is a repeating decimal, or it is a terminating decimal. Now, of course, on contrast, an irrational number is going to be something that's not a fraction of integers, something that's endless and that is not repeating decimal. Can you go backwards and find the missing side of the square? So this is saying this is the missing side, so I'm missing the side length. Explain how you go from area to one side of a square. So here's my area. So my area is 16, and you should have done this in the third grade previous page. How do I go from 16 if my area is 16 to the side length? So whatever you think, go ahead and pause the video and write it right there. Okay, welcome back. So instead of saying what you just said every time, what we say in math is square root of 16 meters squared. Mathematically, that looks like this. Okay, so the square root of 16 will give me my side length. And what is the square root of 16? Now, you may not know this right now, so we'll do it in just a second, but I'm going to go ahead and put it here. So here's the square root symbol. And 16, the square root of 16 is 4. All right, so why is the square root of 16 4? Because remember, if all the side lengths are 4, area is base times height, so 4 times 4, which is equal to 16. All right, so is the side rational or irrational? So the side is 4. Is that rational? Can it be written as a fraction of integers, a repeating decimal, terminating decimal, or is it not a fraction of integers? Is it endless and not repeated? Well, if it's the number 4, just like 25, right? If it's a whole number, it can be written as a fraction of integers by saying 4 over 1. So this is indeed rational. Right. It then says, okay, so the side length we have found is 4. The question is now, what is the perimeter?
Secure the perimeter! Secure the perimeter!
Perimeter secured. Secure the perimeter. Secure the perimeter means just go around the whole shape. So if I add everything around the whole shape, I'm going to add 4 how many times? 1, 2, 3, 4. So I can say 4. In fact, I'm going to do both. I can say 4 plus 4 plus 4 plus 4. But a faster way of mathematically writing this is in multiplication. I can say there are 4 sets of 4, and both of those will give you 16. So the perimeter is 16 meters. Notice it is not 16 meters squared because I'm not multiplying. I am adding all the way around. All right. So let's talk about perfect squares. We read this table as the square root of the area is the side. So if I want the side, I take the square root of the area, I'm going to get the side. Or we can read it backwards and say the side squared is equal to the area. So if I'm given a side and I want to find the area, the side squared will give me the area. Side squared would be 1 squared. And to get the squared, you're going to do shift 6. And then squared, or you can hit this one or this one, whichever one. So 1 squared, which means 1 times 1 is equal to 1. All right, so we already have both of them here. So 2 squared, which means 2 times 2, which is equal to 4. Or I can go backwards. The square root of 4 is equal to 2. And again, let me prove that to you in the calculator. All right, so now I have 9. I have the area. So to get the side, it's already been squared. I have to go backwards with the square root. So square root of 9 is 3. And again, what that means is 3 times 3, or 3 squared, is equal to 9. And I will show you 3 times 3, same thing, okay? Square root of 16 is 4, because 4 times 4 is equal to 16. So again, it's just going forwards and backwards. Square root of 25, you're asking yourself what times what is 25, which is 5. Square root of 36, what times what is 36? 6. Square root of 49, what times what is 49? 7. This one is blank, so obviously there seems to be a pattern. It's going 2, 3, 4, 5, 6, so this is 8. So if I have the side length to get the squared, I go 8 times 8, or 8 squared, which is 64. All right, square root of 81 is 9, and again, you can go ahead and just put these in the calculator and you'll see. Square root of 100 is 10, all right, and then 11 squared is 121. 12 squared is 144, and I'm just going to let you fill out that last one. So what is 13 squared? You can go ahead and put it in the calculator. 13 times 13. So here's our practice. Hint, label each side of every square, and it makes it third grade, just like example 4 on the previous page. So what we're saying is, again, if you're given the area and we want to go to the side, remember you have to take the square root. If you're given the side and you want to go to the area, then you square it. So right now we are given the area, which is 81. So to find the side, something times something was 81. And if you look here, your area is 81, your side length must be 9, because 9 times 9, right, base times height is 81. So your side length is 9. Is your side length rational or irrational? So once again, 3 things for it to be rational. It can be written as a fraction of integers, in other words, a whole number, which it is, so that makes it rational. All right, then the question right here is, how do you find the perimeter? Remember, there are 2 ways to find the perimeter. I can add all the way around, but a faster way to do it, because this is a square, I'm going to have four sets of 9s. 1, 2, 3, 4. So instead of adding all the way around, I'm just going to say this is 4 times 9. So this is equal to 36. All right, so now I'm going to do example 11. You go ahead and do example 10. What is the base length of this shape? So notice there are 3 squares. So it's asking what is the length from here all the way to here. We'll have 3 squares. I know how to find one individually. I just did it, right? So here, this one, the area is 4. How would I find the side lengths? I would take the square root of 4. So this base here is the square root of 4. Then the base of the big square is the square root of 100. And then the base of this one, which is the area is 49, is the square root of 49. And of course, to find the total length, what would I do to those 3 numbers? I would go ahead and add them. Again, we can put this in the calculator, but we've kind of just already put our calculations here. Square root of 4, so the area is 4, is going to be 2, so that's going to be 2. Square root of 100 is 10, so that's going to be 12. Square root of 49 is 7, so this is going to be a total of 19. And again, you can type this whole thing into the calculator. All right, so now that you know that, go ahead and do example 10. What is the base length of this and this? And as an extra question, can you find the applied perimeter? And I'm going to give you a hint. Be careful when you're trying to find this length here. Okay, so I think you can do this one, this one, this one, that one, that one, that one. Just be careful around here. So this is just as an applied. Can you think through how would I find this missing side here, so I can find the perimeter? Now the question is, what if it's not a perfect square? You just leave the answer in radical form. Again, what's the square root of 45? It's not on our little cheat sheet. I have the square root of 49, square root of 64, square root of 36. You're just going to leave it square root of 45 in the answer. It is going to give you a decimal that is going to be irrational because it's not going to be a whole number. Now that you know that, and let me go ahead and say this 19 was rational. Now that you know that, find the perimeter. Okay, so again, the perimeter of the shape is all around the shape. How many square roots of 45 are you going to have? 4 of them. So this is 4 square root of 45. We're going to come back to this simplified version a little bit later after we go over how to simplify. All right, so go ahead and tell me, can you find the area of these two? So what would I do to these two numbers? Right, on this one, example 4, can you find the base length? So that's this piece right here. Again, leave your answer in radical form. And don't worry about the simplified. We will come back to that. Let's practice.